Today we're talking about the Python client. I have a couple slides here. First, just to give you the context of AllegroGraph, and these are general, and then we'll get into the actual demo. So AllegroGraph is Franz's RDFStore. It's scalable and persistent, which means that the goal here is to have something that's really industrial quality, and just like databases can scale and be robust and be used with very high reliability, that's the same goal here for the Franz RDFStore. Also, it's federated, and this is something not related to our demo, but you can run the store on multiple machines, not just one, in particular the Amazon Compute Cloud. And it's being designed so that when you go federated, it's transparent, so that you can treat it as if it's just a single extremely large store. There are more than one kind of way of accessing language-wise. Sparkle is the language that most people use. You can also use Prolog, and then there are other reasoners that can be run against it. And Franz is very dedicated to standards, so RDF, RDFS, OWL, Sparkle, all the different standards that are related to RDF stores are supported by Franz. There are some advanced features in the product. So besides very high performance and very large stores, Franz is also working at extending what you can do. So there's many different data types that you can do range queries on. What we discovered early when using AllegroStore is people immediately started doing inequality reasoning, even though that wasn't something that is considered a strong point, and so it's become a strong point in the Franz product. Spatial reasoning, there's special primitives for that, also for temporal reasoning. Those aren't actually in the Python product yet. We still have a little more work to do there, but you can be sure they're coming, and they're already in the primary product. Finally, social network analysis is another place where there's an extension to what you would get in a sort of more vanilla product. There's many different ways to interface, so that there's a server, and you can access it from Java, you can access it from Python. There's also a C# interface. And within the Java world, there's actually a couple different interfaces. There's the Sesame one, which is, there's OpenRDF is a, actually there's OpenRDF, which is a open source working group, and then there's Aduna, which is a commercial company that's backing OpenRDF. And that's the Sesame product. And then there's Jenna, which is a much older interface, but there's still a lot of people out there that use that. The Python that we're going to be showing you today is modeled after Sesame. So rather than invent things, from scratch, we chose to take something that's out there that's already being used by a rather large number of people. And they are all using it with the Java API. We're mimicking that syntax in Python, and so I'll be showing you that. And then there is a REST interface, meaning you can just go through a straight HTTP and talk to AllegroGraph, and that's a very, very small client, and that means you could be pretty much any language at all. So right now, if you're in Ruby, that would be the easiest way to talk to AllegroGraph, is to go through HTTP. The interface I'm going to be showing you actually is, it's a full-blown API, but it's talking through the HTTP as well. So everything you're doing squeezes down into a much smaller interface to actually get the work done. Let's see, I now want to switch to Eclipse. So what I'm going to be doing is demoing in Eclipse, and I don't know how many of you are used to it. So I've set up the windows for a way that seems pretty good for demoing here. There's one thing I cannot do in Eclipse, at least I don't know how. In Emacs, you can have two windows open on the same buffer, and I don't know how to do that in Eclipse. So I'm evaluating out of a buffer, and here you can see that what this is a Python program, and it has test 0, 1, all the way down. And then the way Python works is there is a main section, and when you evaluate the file, then it runs the main. So I'm going to be doing that. However, I want to be in two places at once. I want to be able to show you what tests we're looking at, and also I want to be at the bottom picking which test I'm actually running, and I can't be in two places at once on the same file exactly. So I have two files here. There's a tutorial examples file, and then there's a copy. And when I edit the tutorial one, like I stick a 1 here, and then execute, I'm going to be executing that file, but I'm going to be looking at a separate copy of the file just so that I can be, as I said, in two places at once. So what we're going to do is we want to evaluate test number 1, and when I say execute, it's going to be running that particular one. However, first let's just talk about, I want to go line by line and say what's actually happening here. Okay, so what we are doing, we're running in Python. I've already got a server running. So before any of the Python, I executed an application. There's an AllegroGraph HTTP server which is running, and that's what I want to talk to. It's running on my laptop, so I'm going to be using localhost, and it's serving port 8080. So I want to talk to localhost port 8080, and that's what this first line does for me. And so when you're running your own Python applications, you'll do the same thing. You'll get an object back of the class AllegroGraph Server, and that will establish an HTTP connection to the other server running. Okay, the first thing I did was I wanted to print available catalogs, and let me switch slightly just to give you an idea of what's actually happening there. Try this, let's see. So here, if I go to look in /temp, I have inside of /temp, there's a directory called AG, and that's where I'm putting some triple stores. And let's just do a list, and we can see AGraph test, AGraph test 2, AGraph test 3. These are just places I'm messing around, but those are different triple stores. Okay, so when I say catalog, list available catalogs, and let's actually run this. It says available catalogs AG. So when I first started the server, I pointed it at /temp/AG. I said that's a catalog out there that contains some triple stores, and that's what I want you to serve up. I could have actually listed several, not just one. But at this point, the server is looking at one. So I can see AG, and that contains one or more triple stores. Now, the word repository is the preferred term if you're talking in Sesame vocabulary, and that's what we are doing here. So instead of calling them triple stores, we're calling them repositories. We first opened the catalog to AG, and then we said print available repositories in that catalog, and it's going to print out, and we can see on the right side the output. And it says test 3, test 3.4, test 4. What it's doing is listing the triple stores that it's found inside of that particular directory location. So we want to pick one, and we're going to pick AGraph test 4 and create a repository object for that. And then we initialize it, and then we're up. Okay, so what we've done is we've first locked onto the server, and then we said we want to actually pick a catalog, and within that we want to pick a repository. and now we've locked onto it, and now everything else we do is with respect to that particular repository. You could actually have more than one open at the same time. We're not going to do that, but we certainly could. The other thing is, when I chose the repository, I said which one I want. That was AllegroGraph test 4. I also said, how do I want to open it? And this is something that in any time you're using AllegroGraph, meaning in the Java version, I'd also have a set of choices. I can say renew, I can say create, I can say open, I can say access. And they do slightly different things. Renew says, I'm going to wipe out any pre-existing triples and start fresh. If I said access, it's saying whatever's there, let's use it. If I say open, it says let's, again, whatever's there, but if there's nothing there, it throws an exception. And if I say create, it means I want to create something new, and if it is already there, that's an error, so that throws an exception. So the different possible cases have all been enumerated. Renew doesn't make much sense for a true application because you're wiping stuff out, but when you're demoing, it works actually extremely nicely because it means that you get to start fresh every single time, and any data you put in, you won't have to worry about possibly having different answers because of different things you've done. So in this demo, it's actually going to be calling test 1 repeatedly and starting from scratch repeatedly, and that just works really, it's very handy for demoing. By the way, questions, if you have any, you're welcome to ask them. I won't hear them, but Steve will, and he'll relay them to me if he thinks we want to stop and answer a particular question. And again, of course, we'll have questions at the end.
Bob, just to let you know, this is Steve. We've had a few questions come in, and we're answering them as they're coming in. So, again, if anybody has questions about what Bob is showing, let me know now, and we'll see if I can unmute you. Otherwise, Bob, go ahead.
Okay. So what we've done so far is test 1, which is just to get hooked up, and we haven't actually done anything interesting yet. So let's move to test 2, and what I'm going to do is type in a 2, and we can execute it already, but I haven't told you yet what the lines of code are for. So I'm going to go line by line a bit more slowly now and test 2. Now, the Sesame interface that we're imitating is somewhat verbose, and that's not really a bad thing because what we've seen is that if you put in sugarcoating in an API, almost everybody tends to invent their own anyway, and that's kind of the recommendation. We're giving you the building blocks here, and if you wanted to do stuff that was more abbreviated, you just write your own functions on top, and you call those and they call these. But we've seen most of our customers always like to go and do things that are a little bit more tailored for their particular environment than what a completely general thing is. So here we're giving you the basics, and I think that's actually a good choice by Sesame. So there are actually 3 objects that you manipulate when you're using Sesame. Everything comes down to the repository, meaning the triple store we're using. But they require you to create 2 other objects. One's called a value factory, and one's called a connection. So this line 39 here, we take the repository that we have created in step 1, and we call getValueFactory, and F stands for factory. That's an object that is used to create terms. So if you want to create URIs or literals, then you have to call the value factory. There's a second object called a connection, and on line 48, we're calling getConnection to create a connection object. And when you want to actually do queries or updates, you talk to the connection object. And it's a little bit arbitrary seeming. If we were doing the interface and trying to make it as simple as possible, we would only probably have one object called a repository. Sesame has 3, and they have a more complicated architecture that sort of has reasons for those 3. So that's just kind of how things how things work, and that's how we're doing it. So first what we need to do is create a few objects. So we have a couple people, Alice and Bob, and we want to make a couple statements about them. So we create a URI for Alice, we create a URI for Bob, we create a property called name, and another property called person. And then literals, one literal contains the name Bob, or the string Bob, and one contains the string Alice. So what this first thing we've done with the factory is create 6 objects, 4 URIs and 2 literals, and now we can start building statements out of those objects. Okay, when we executed, then I ran this code earlier, and the result was on the right. At this point in the code, we printed out all the triples, and we asked, what is the size of the repository? And the answer came back 0, because we haven't actually created any triples. We've created some objects, but we haven't created triples yet. Okay. The next thing we want to do is create some statements. So the first thing here, line number 52, it's an add triple. So we have Alice in subject position. RDF type is built into the Sesame, that a bunch of the common predicates you can just access. And so we're saying Alice is of type person, and person again is the URI we created. So that adds 1 triple. Then we can say Alice's name is, and then the literal Alice's name, that's the second triple. Bob is a type person, and Bob's name is Bob's name. Now here I didn't actually have to do this, but I was showing instead of predefining the name, I could have just put it in line. So I have 4 triples now. When we executed our code, at this point, the triple count was 4. Okay, if we look over on the right, we see what had happened after we'd done the 4 inserts. And then we can do a remove here. Line 60 says we're going to remove Bob's name being Bob's name, and then again we print out how many triples, and now we see there were 3 instead of 4. So this is pretty simple, but that's the whole point, is that it's really easy to add things and remove things. Okay, when we move on to test 3, in line 66 we're calling test 2 and getting connection. So in this demo, I'm going to be using these 4 triples over and over for the first few simple examples. And that's what's happening here. Test 2 called test 1 to get started. Test 3 called test 2 to get the repository already containing 4 triples. By the way, all this test code we're publishing. So I'm showing you today, but you'll be able to single step exactly the same code to get started yourself, and you can play with it and change things however you want. This is a really easy way to get introduced to how things work. So let's move to test 3 here. Okay, now I'm going to execute it, and I just ran the code in test 3. What we're doing here is a Sparkle query. So we have our 4 triples from before. We build a Sparkle query here, and the way you do queries in the Sesame interface is you first do a prepare, and you get a query object back, and then you evaluate it. And this is imitating how things are done if you're used to databases in a JDBC. They have a prepare for a SQL query, and that creates the query object, and then you can execute that query over and over if you want. And it's the same thing here. We're only going to execute it once, but this query object we could execute more than once if we wanted to. In the actual Sesame, they have a separate language besides Sparkle that has parameters in it, and that's, I think, why they invented this separation. Is in that other language, you could do modifications to the query and evaluate it each time. It's the same same query as far as syntax, but you're passing different parameters. And that's something I suspect you're going to be seeing in Sparkle downstream, but Sparkle doesn't have that yet. So we created the query, then we evaluated it, and what we get back is a set of binding sets. Okay, this is, again, the way it's done in Sesame, and it's also the way it's done in Jenna. So this is just the standard way that the community has said that queries go, is that you do a query, and what you get back are a set of binding sets. Okay, that's a set of sets, a bit of a mouthful. So each binding set is one row of that query, and what the binding is binding of the variables S, P, and O. So when I run the query, the first row will have a binding for S, a binding for P, and a binding for O. And here we're printing them out. We're saying get value of S, get value of P, get value of O, put them in the variables S, P, O, and then print them. And if we look on the right here, we're going to see things print out. So let's move over. So we ran the query, and we saw it prints out Alice, prints out RDF type, and then prints out person, 3 UPIs. Then it says Alice has name Alice. Then here's Bob has type person, and Bob has name Bob. Now the output here is exactly what you would get if you were running in the Java version. So again, we're not merely mimicking the syntax on input, but we're trying to say when it prints out, it's going to look the same as if you were running the Sesame version in Java, and that's what you would get. They also have close operators, both for results and for connections. Right now, if you fail to do a close in the AllegroGraph, I don't believe you paid any penalties. But there are systems out there where it matters, and it could well be that downstream AllegroGraph will have a more complicated setup so that closing is important. So we have that syntax implemented now, but right now these are just no-ops. If you do a close, the system is happy that you did it, but it doesn't actually care very much. So far now we've created 3 triples, and we have done a query that prints them back out. Okay, moving on to test 4. Let's create a 4 here. And run it. This is going to show a different way of doing with, you can either do a Sparkle query or you can do what I call a match. And the verb here or method is called get statements. Get statements takes either 3 or 4 parameters. Right now we're showing it with 3. Later we'll show 4. And you put in either a none, which is a wildcard, or you can put in a literal or a resource, which is going to say I want to match that particular thing. So in this example, we're saying we want to match triples where Alice is in the subject position and we don't care what's in the other 2. So we run that, and then we have an iterator that says, well, iterate over the statements and print S each statement. And then if we look on the right, let me push this a little farther. It prints out, we see Alice, type person, Alice, name Alice. So the 2 triples that have Alice in subject position matched. Now we have an extension, another call called get JDBC statements. This is not in the Sesame standard. Instead, what we're doing is mimicking what you would find in the database world and getting back a result set. And it's just a slightly different protocol. You call next, next, next on this. The feature here is that it doesn't actually force the generation of objects. So in the earlier one, every time you ran, you got a statement object. And inside of that, you had 3 value objects that were either URIs or literals. If you're using the JDBC thing, everything is all strings. However, what we have not noticed is that the JDBC is particularly faster. It generates less garbage, But if you're doing benchmarks on speed, it seems to be about the same speed as if you're not using it, if you're using the object-based thing. So we don't have any recommendations here. It could be downstream that calling the JDBC version is going to be good and that your garbage collector may not be quite as busy, but we don't actually know that yet. So this is just something right now. It's an experimental extension. Okay, let's move on. We're going to gradually get a little more complicated here. Test 5 looks at type literals, and it's actually a pretty lengthy test, and I'm not going to go into all the details. So I'll run it and I'll talk about a little bit of it. And then this is the kind of thing that you're invited on your own when you have this exact same code. You can go over it and peek and see what happened. We're imitating the syntax for Sesame for creating literals here. So when you're creating a literal, I'm just going to point at a couple things. Here we're calling the factory and passing it the string red, and so it created a string, pretty vanilla string. We could have, here we're saying the next line, a string rouge, but we're telling it that it's actually French. And so that literal is it's got internal structure to it, both a string and a language. After that we have create literal, it's a string 42, but we're telling it's an integer. And that means the system knows that this is an actual integer, and then it's going to be treating it internally as the integer 42, not as the string 42. We're doing, again, various literals, creating dates or longs or floats. When we actually run the queries, and I'm not going to go in detail here, but this is the kind of thing you can look at yourself, depending on what we pass in, things match very differently. So in this one loop here, we're passing either the string 42, well, it's removing a set of quotes when it's actually getting it. When I pass this string 42 into a Sparkle query, it sees just 42, and that actually turns into an integer in Sparkle. If I pass the quotes around it, that's the string 42. That will match something different in Sparkle than the integer 42. Farther over here, I have a 20.5. So this says it's a float. And so there's a whole bunch of variants here. And on the right, it's printing out answers that are all different depending on what kinds of things you passed in. So this is just giving you an exercise in how you actually treat literals. And Sparkle treats them all very differently, which if you have a string of type string, that's actually different than a string that is completely untyped. And you'll see that if you're looking carefully at these examples. And a string red that is type English or language English doesn't match a string that doesn't have a language attached. So if you start experimenting that way, you'll see these differences. Again, we're following the standards here as closely as we can. Okay, moving on to 6. Here what we're showing is instead of just working with 4 triples, pretty soon you want to graduate to actually having a file full of triples. And that's what's going to be happening in step 6. So I'm going to execute it here, and it's going to read everything and then print stuff out. So let's actually look at the, there's not much output yet here. I'm going to be using step 6 over and over, but here all I did is load some triples and then said how many did I get. Okay, so let's go over here and see what I did. I got the connection for step 1. I called clear just in case there were any triples there that I didn't want. And then I have pointers to 2 different files. One is an RDF file, which is vcards. That's pretty standard in the Jena world. Another is an ntriples file, which has just some statements about football in it. And these are triples. And I'm going to read both of these in. And I haven't been talking about context up to now. I've been talking about triples. But AllegroGraph is a quad store, so that we actually store everything as quads. There's a context argument associated with each triple. Now the word context is, in RDF terms, more commonly called graphs, and that is a matter of taste. Some people call them graphs, some people call them context. It's the same thing. In the Sesame world, they use the word context, and so that's what we've chosen to use here when we're doing the API. But if you're used to the word graph, then every time I say context, you want to think graph. When you read a file of triples, you have to decide what graph or what context you want them to be put in, because that fourth argument has to be there. If you don't give it a fourth argument, then it gets put in what's called the null context. And if you do give it a context argument, then whatever context you load it into has just got some more triples. So when we run this thing here, the verb is either called add or add file. My preference is the longer one, but the actual Sesame, you say add, and it has to figure out on its own. There's three adds. There's an add statement, there's an add file, and I'm forgetting what the other one is, but we have long versions and short versions just to try to be compatible and, or clear, whichever you prefer. So I'm adding two files. One is an n-triples file, and there it says context equals none, and what that means is that we want to load into the null context. On the second one, I'm using add file and saying context equals context, where context I defined up above. I called the value factory. I created a URI. I put a path in it. I could pick any path I want, but I happen to pick one that is similar to where I actually read the file from. And so I'm loading in some triples into the null context. Other triples I'm loading into a context, which is the vcard context. And then I'm calling index triples. And this is something which says we've just loaded some triples, and we want to make sure the indices inside of AllegroGraph have been efficient. And it doesn't quite know when you're loading, when you're all done, so right now you call index triples, and that's basically saying, I'm done, now could you make it efficient, because then queries are going to run faster. In later versions of AllegroGraph, index triples won't actually be needed anymore. The system's going to figure out on its own when to call it. But at the moment, it's still there. We're calling it, we can either say index all triples or just the ones that are new, and we can say, should you wait while we're indexing, or should you just start indexing in parallel? And we've chosen to asynchronous false means index, but we don't have very many triples, so it's not like this takes very long. But if you loaded 100,000 triples and said index, you might not want to wait. Okay, so what did we do? We loaded two files. One was an RDF file, one was an n-triple file. We put them in two different contexts. One was the null context. One was the context that had the vcard name, and then I printed it. So we asked, what is the size of each context? And over on the right, we discover that there are 16 vcard triples, 28 triples in the context, the null context. Again, the word null context is a Sesame phrase. It's very commonly called the default context by people, or default graph by people that use the phrase graphs. The phrase default graphs is a little bit confusing because there's also a notion of multiple default graphs in Sparkle. And then when you say default graph singular, you have to realize that means something different. When we say null context, there's not any ambiguity. There's exactly one null context, and that's what you get when you have triples that didn't specify any other context. So we have loaded our triples. Now, in test 7, we're actually going to match against them. So test 7 calls test 6. It's going to load the same triples as before. And then there's a get statements here, and we've said none, 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 none. And what we're saying is that we have wildcards in all positions, so we should get all the triples back. And they're all here. Okay, so let's see, we didn't actually print, we just printed the subject and context, okay, line 172. We got all the triples back, but we didn't want to see all 4 values. So here we're seeing England with none, 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 Netherlands, none, none, none. These are some of the soccer matches. And then later, actually, I'm actually confusing myself a little bit. We have more stuff coming out. There's what I'm getting. The reason I'm pausing slightly is the word none. We're finding a slight ambiguity with. Does none mean a wildcard? Does it mean the null context? And there's no ambiguity in the Sesame spec, but there is room for a lot of confusion. When I was putting this whole demo together, I managed to get myself confused because the word none as a wildcard means completely the opposite from none as the null context. And when you see it in context position, you have to sort of wonder which one is actually meant. If you see it inside of a list, so if I look at line 165, none inside of a list means the null context. If you see none outside of a list, it could actually go either way in the Sesame spec, and that's quite confusing. What we're actually experimenting with is, and I'll just show you by typing here, if I said the string null, that would be unambiguously the null context. And I think that would actually be a much cleaner way of making this distinction. That's not the way Sesame does it, but given that we're confusing ourselves when we're doing this, we're actually thinking that maybe that's what would be a good way to be done instead. We've done some experimenting with that. Right now, we're just saying we're probably going to support both, but if you use the string null, you're more likely to be getting it not confused. And so we loaded everything in, then we can print out some statements. We can either do a get statements, or there's the same thing in Sparkle, or at least a similar thing. Printing out, we want subjects and C for context where there's a graph match. However, Sparkle is not going to match the null context. That's just the way Sparkle happens to be built. So if you actually ran Sparkle, you wouldn't see the null context coming out in this particular query. We're going to keep moving on. Actually, I guess I'm looking at the time. I'm being kind of slow. So let me talk about this stuff, but not necessarily execute it all. So far, we've been reading quirples in. We've been querying them a couple different ways. If you want to write it out, we've imitated the notion of writers that's in the protocol. There's an ntriples writer, and there's an RDFXML writer. And the way these work is you create a writer, and then you call export, and you tell it what context that it's writing out to. So you've told it where you want to write, and you give it a name of a context, or you can give it null, but for the null context, and it's going to write out either ntriples or RDFXML into whatever file you pointed at. Okay, pretty straightforward. There's also something called export statements. Here, what we're saying is instead of writing out a context, a graph, which is all or nothing, you can do that whole context, but you can't do a part of it. Instead, you can specify subject, predicate, object, and whether you want inference on or not. And that will write out triples that match. And it uses a writer. So that way, if you wanted, in this particular case, test 9, let's just run it. I run test 9. I say I want to print out type statements. And I'm actually, by passing none to the writer, I'm saying I want to print it out to standard output, not to a file. So here we're seeing all the stuff coming out right to the screen. and these are all type statements, okay, in RDFXML format. Okay, moving on, if we have multiple contexts, one thing that's a bit unusual about Sesame, you don't see these in other interfaces, is that they're big on being able to do lists of contexts when you're actually printing stuff. So here we're back to having just a few triples about Alice and Bob and Ted, and we have 3 contexts. One is context 1, one is context 2, and the other is the null context. And when we run 10, which I don't think I've done yet, let's run it, then depending on what I ask it for, I'll get different answers. So if I say get statements and I don't say anything about context at all, I omit that argument, that's the wildcard. It means print everything. If I list 1 and 2, I'll get just what's in context 1 and 2. If I say none and 2, I get the null context plus context 2. And if we look on the right, the wildcard got all 6 triples. If I said 1 and 2, then I'm getting triples here, and the context argument's way over to the right. We can see context 1, context 2 coming out. And if I said the null context in context 2, we see the 2 triple with context 2 is, and the other ones, the context is just missing. We don't print out anything if it's a null context. There's just nothing there. Okay, and that's, he calls it the null context, is because it doesn't exist, is the way I think of it. In Sesame, the statements either have 3 terms or they have 4. If it's a null context, they just have 3. If it's any other context, then there's a 4th term, which is the context itself coming out. Let's see, we're almost done here, actually. A couple of more things. One is namespaces. So in test 11, what we've done is said you can if you're going to want to use prefixes, like in a Sparkle query, let's just look at the query here. There's EX:person. Well, you could have said prefix before the select and then gone EX: and then said what the namespace was. But rather than do that over and over, you can just create a namespace, and then in your Sparkle queries, they don't have to have the prefix declarations. So we did that here. We created, there's a namespace here. We put it in the variable, or we could have just, we could have inlined it. Okay, I could have taken that code there and just popped it right in, except I lost my quote. Okay, set namespace says that EX has this namespace, and for the whole session that you're running, that binding can be used. So that's the convenience. It's quite convenient. So we encourage people to do that. The last example we're going to show is, and by the way, I'm not running the other one. I'm just telling you that's a nice thing to have. If we're doing free text search is telling the system that there's a special predicate, which is the FTI:match predicate. Free text index: match, I think, is what FTI is shorthand for. This is a feature that's it's built into the language in an extension. Okay, so our select query, and I guess I should have started with sooner, we're going to have a few triples here, and then we're going to be looking for triples where we're matching against the string Alice. And the syntax here, there's no filter being used in the Sparkle here. And the reason is this is a generator. We're actually generating bindings for the subject S. What's happening is any triple where there is an Alice going to be occurring in object position, we want to bind the subject of that triple to the variable S. And that's what this query does. We first have to tell the system, though, that we're going to be doing free text search. So before we do the query, there's a call to the repository and a register free text predicate. And what we're saying is we're giving it a namespace and a local name. Together that forms a URI. And we're saying that this particular, we want to index full names in this particular case. So this is an extension. There is no such thing in the Sesame API. And if you had multiple free text predicates that you wanted to index, so we could have also indexed one called name. You call register free text predicate for as many things as you want to register, and it'll index all of those, and then you can use this predicate here. If we actually run it, and let's do that. What it did was look for things where there was an Alice in third position, and I had, let's see, it found Alice to be tokeless, and it gave us back an F saying there's a subject, Alice 1, who had an Alice be tokeless, but we were actually printing out all triples with that subject, not just the one that had Alice in it. So that was actually a couple triples coming back. You would have to look at the 4 statements that I asserted to see how that makes sense, but it gave us back the match that we were looking for. Okay, so that's free text search. This is an extension beyond the regular Sparkle language, but free text search is something that's actually implemented in a lot of different systems. It's implemented a little bit differently in each one because there's no standard way of doing it, but it's quite useful. I'm not going to demonstrate range predicates, but this is something coming in the future, another extension to the language. We're also going to be doing geospatial in the future, so you won't have that next week, but you know that it's coming. A few other things in the language: ask, construct, and describe. There's examples of how to do that. So that's pretty much it. That's what I wanted to show you, but if I wanted to summarize, you now have a way in Python of accessing AllegroGraph Store. As far as I know, this is the only high-performance store that's accessible from Python. I've used another which is kind of very slow and doesn't support all of Sparkle. I imagine others are coming, but this is a heavy-duty implementation. When you download, you're getting the same performance in server side as if you were using Java. We've seen the Python language is a little slower than Java, but we've heavily optimized this. In fact, you're going to have to download something called PyCurl because we've discovered that the native HTTP is a bit slow, but the C version is very fast. And so when you use this version of the client, you're going to have to download the very fast curl HTTP client code, and then you'll be able to run all of this code, and it's quite performant. Okay, so now I wanted to open for questions.
Okay, so the floor is open for questions.
So regarding the Python API, can you hear me all right?
Yes, we can hear you loud.
Cool. So the range, temporal, and geospatial queries aren't baked in yet, but they are available via the Prolog interface in Python. Did I get that right?
That is right, yes.
Okay. And also in test 5, I thought I caught the add method of the connection object returning a statement reference. Is that correct? For referencing assertions? Yeah, I think, let's see, line 117. Yeah, no, it was a create statement. And so that statement 1 reference can be used for reification and working with the assertion of the f.create statement. So, for example, I could insert a line after 118 and make another assertion about statement 1 and or 2 via Python.
You mean the direct reification that we support in the
Java API?
Yeah.
But your overall intention is for the Python API to have the same power as the Java API, and the Java API has that convenient object-oriented reification access thing going. So you guys are planning on putting that in the Python API as well, right?
I haven't discussed that with Bob yet. It's not really part of Sesame, the direct reification thing. It is something very, very AllegroGraph specific that we do. If you need it, we can So we would break the Sesame API, but we'll see what we can do. I mean, yes,
Well, I'm sorry, go ahead.
well, it's extremely handy to be able to point to other statements directly. I agree.
Yeah, it is. It's really cool. I think it's the best. It's one of the coolest powers of AGraph. And for provenance, I'd love to be able to talk about provenance in Python.
Yeah. Okay,
That's my bit. Thank you.
Somehow we lost Bob, so I'll discuss it with Bob.
Awesome.
Okay.
And I guess one more question: does your team use PythLogic, the Python Prolog interface, or do you guys build your Prolog queries in Python just with string concatenation?
Now, what we basically do, you create the Prolog string in Python, and then you send it off to the server.
Okay, so you guys haven't played around with PythLogic?
I've never done that. No.
Okay,
I think that actually also would be difficult because, I mean, if you do a large Prolog expression, it would be almost like doing a relational database join in the client. You know what I mean? So maybe you can use the Prolog on the client side, but the way we do it is just send the Prolog to the server.
Okay, that helps
Yeah.
give me some context. Cool, thank you.